NENOMATICA, where mathematics meets YouTube excellence. Welcome to our math lesson on multiplying monomials. Today, we'll learn how to multiply algebraic expressions with multiple variables and exponents. Let's look at an example. 4x times y cubed times z multiplied by 5x squared times y times a cubed. To multiply these monomials, we'll follow a step-by-step approach. Step 1. Let's separate the coefficients and like bases. We've organized our expression by grouping like terms. We have the coefficients 4 and 5 grouped together. The x terms are grouped, the y terms are grouped, and the single powers of z and a cubed remain as they are. Step 2. We multiply the numeric coefficients. 4 times 5 equals 20. Step 3. We add exponents for like bases. For x, we have x to the power of 1 times x squared, which equals x cubed. For y, we have y cubed times y to the power of 1, which equals y to the fourth power. Step 4. Now we can combine all factors to get our final answer. 20x cubed, y to the fourth power, z, a cubed. Quick challenge. What happens if you multiply by 3x instead of 5x squared? Pause the video and try it on your own. The answer would be 12x squared, y to the fourth power, z, a cubed. We would have 4 times 3 equals 12 for the coefficient, x times x equals x squared, and the rest remains the same. Remember the key rules for multiplying monomials. 1. Multiply the coefficients. 2. Add the exponents of like bases. 3. Keep any unique bases with their exponents. Practice these rules with different examples to become more comfortable with monomial multiplication. Welcome to this tutorial on algebraic multiplication. Today we're going to learn how to multiply algebraic expressions involving variables with exponents and coefficients. We'll go through several examples step by step to help you understand the pattern for these types of problems. Before we dive into the examples, let's review some key rules for algebraic multiplication. When multiplying terms, we multiply the coefficients separately from the variables. When multiplying the same variable, we add the exponents. For example, x squared multiplied by x cubed equals x to the fifth power. When multiplying different variables, we keep them separate and add their respective exponents. For example, x squared times y cubed remains x squared y cubed. These rules will help us simplify expressions as we work through our examples. Let's begin with our first example. We need to simplify negative 3x squared times 5y squared. First, let's identify the coefficients and the variables with their exponents. The coefficients are negative 3 and 5. The variables are x squared and y squared. Now, we multiply the coefficients. Negative 3 times 5 equals negative 15. For the variables, we keep them separate since they are different variables and maintain their respective exponents. So our final simplified answer is negative 15x squared, y squared. Let's try another example. Here we need to simplify 4x squared, y times 1/2 xy squared. First, we'll multiply the coefficients. 4 times 1/2 equals 2. For the variables, we group them by type. For x, we have x squared from the first term and x from the second term. So we get x squared plus 1, which equals x cubed. For y, we have y from the first term and y squared from the second term. So we get y to the power 1 plus 2, which equals y cubed. Therefore, our final answer is 2x cubed, y cubed. Now, let's look at a slightly more complex example. We need to simplify 6xy times 2y squared times 1/3 x squared y. As before, we'll start by multiplying the coefficients. 6 times 2 times 1/3 equals 4. Now for the variables. For x, we have x from the first term and x squared from the third term. So we get x to the power 1 plus 2, which equals x cubed. For y, we have y from the first term, y squared from the second term, and y from the third term. So we get y to the power 1 plus 2 plus 1, which equals y to the fourth power. Therefore, our final answer is 4x cubed, y to the fourth power. Let's try a more complex example with more variables. We need to simplify 4x squared, y cubed z to the negative second power times z times xy to the fourth power times w. First, we multiply the numerical coefficients. Here we only have 4, since the other terms don't have explicit coefficients, so they're understood to be 1. For the variables, we group them by type. For x, we have x squared from the first term and x from the third term. So we get x to the power 2 plus 1, which equals x cubed. For y, we have y cubed from the first term and y to the fourth power from the third term. So we get y to the power 3 plus 4, which equals y to the seventh power. For z, we have z to the negative second power from the first term and z from the second term. So we get z to the power negative 2 plus 1, which equals z to the negative first power, or simply z to the negative 1. For w, we only have w from the last term, so it remains w to the power 1. Putting it all together, our final answer is 8x cubed y to the seventh power z to the negative 1w. Let's look at our final example. We need to simplify negative 3x squared times 1/5 ya squared. First, we multiply the coefficients. Negative 3 times 1/5 equals negative 3/5. For the variables, we group them by type. For x, we only have x squared from the first term, so it remains x squared. For a, we have a from the first term and a squared from the second term. So we get a to the power 1 plus 2, which equals a cubed. For y, we only have y from the second term, so it remains y to the power 1. Therefore, our final answer is negative 3/5 x squared a cubed y. Let's summarize what we've learned about algebraic multiplication. First, we multiply the numerical coefficients together. Then, for variables with the same base, we add their exponents. Different variables are kept separate with their respective exponents. Finally, we combine everything into a single term. Try practicing these steps with different expressions to build your confidence. Remember that the key to mastering algebraic multiplication is careful organization of the coefficients and exponents. Welcome to our lesson on multiplying monomials. Today we'll learn how to multiply algebraic expressions with variables to different powers. When we multiply monomials, we need to remember two key rules of exponents. The first rule is that when we multiply terms with the same base, we add the exponents. For example, x squared times x cubed equals x raised to the power of 2 plus 3, which is x to the fifth power. The second rule is that when we multiply coefficients, we simply multiply the numbers together normally. Let's start with our first example. We need to multiply 4xy times 5x squared y cubed. To solve this problem, let's break it down step by step. First, we can rewrite the expression by grouping similar terms. We'll group the coefficients together, the x terms together, and the y terms together. Now, we can multiply the coefficients. 4 times 5 equals 20. For the variables, we add the exponents. X to the power of 1 times x squared equals x cubed. Similarly, y to the power of 1 times y cubed equals y to the fourth power. So our final answer is 20x cubed y to the fourth power. Let's move on to the next example. We need to multiply 5x squared y cubed times 2x cubed y squared z. Let's break down this expression as well. We'll group the coefficients, the x terms, the y terms, and the z term. Now let's multiply and simplify each part. 5 times 2 is 10. X squared times x cubed equals x to the power of 2 plus 3, which is x to the fifth power. Y cubed times y squared equals y to the power of 3 plus 2, which is y to the fifth power. And z remains as z with an exponent of 1. Our final answer is 10x to the fifth power y to the fifth power z. For our third example, we have negative 3x squared times 1/5 ya squared. Let's group similar terms again. We'll group the numerical coefficients, the x terms, the terms, and the y term. Now, let's evaluate each part. Negative 3 times 1/5 equals negative 3/5. X squared remains x squared, as there's only one x term. A times a squared equals a cubed, and y remains as y. Our final answer is negative 3/5 x squared a cubed y. For our fourth example, we'll multiply 4x squared y cubed z squared times 2x y to the fourth power w. Let's group the similar terms together. We'll group the coefficients, the x terms, the y terms, the z terms, and the w term. Now, let's multiply each group. 4 times 2 equals 8. X squared times x equals x cubed. Y cubed times y to the fourth power equals y to the seventh power. Z squared remains z squared. and w remains w. So our final answer is 8x cubed y to the 7th power z squared w. For our final example, let's multiply 5x squared y cubed times 2x cubed y squared z. Let's group the terms as we've been doing. We'll group the coefficients, the x terms, the y terms, and the z term. Now, let's multiply each group. 5 times 2 equals 10. X squared times x cubed equals x to the 5th power. Y cubed times y squared equals y to the 5th power. And z remains as z. Therefore, our final answer is 10x to the 5th power y to the 5th power z. In summary, when multiplying monomials, remember to group like terms together, multiply the coefficients, add the exponents. For like variables, combine all terms into your final answer. To multiply these expressions, we'll use properties of exponents. Let's first rearrange these terms to make them easier to work with. We'll separate the constant coefficients from the variables. Now, let's multiply the coefficients and combine like variables using the laws of exponents. Remember, when we multiply variables with exponents, we add the exponents. Quick challenge. Can you predict what happens when we multiply negative fractions with variables? Try the next example before we show the solution. Let's try another example with negative fractions. For this expression, we need to pay attention to the negative signs and the power of 2 on the second term. Let's first expand the squared term. When we square a negative fraction, the negative sign becomes positive because a negative times a negative equals a positive. Next, let's simplify the squared expression. Negative 1/3 squared equals positive 1/9. X squared squared equals x to the 4th power, and y squared is y squared. Now let's separate and multiply the constants, then combine the variables with their exponents. Finally, we multiply negative 1/2 by 1/9 to get negative 1/18. Then we add the exponents of like variables. X to the 1st plus x to the 4th gives x to the 5th, and y squared plus y squared gives y to the 4th power. Quick challenge. What happens when we multiply expressions with 3 variables x, y, and z? Try the next example on your own before we continue. Let's move to a more complex example with 3 variables. We'll approach this similarly. First, let's group the coefficients and variables separately. Now, we calculate. 2/3 times 6 equals 4. Then we add the exponents for each variable. X to the 4th plus x to the 5th equals x to the 10th. Y squared plus y cubed plus y to the 5th equals y to the 10th. And finally, z cubed plus z squared plus z to the 5th equals z to the 10th. So our final answer is 4x to the 10th, y to the 10th, z to the 10th. Let's look at our final example, which involves fractions with negative exponents. This example follows the same principles as before. Let's start by grouping the coefficients and the variables. Now, let's look at the coefficients. We have negative 7/11 times 33 over 5 times negative 5 over 21. The negative signs multiply to give us a positive number, and the fractions multiply to give us 1. Welcome to this math video where we'll solve a problem involving a composite figure. We have a shape consisting of a rectangle on top and a trapezoid on the bottom. All sides are labeled with monomials in terms of m and n. Let's first identify all the sides of our figure. The top side of the rectangle is 3m squared n. Each vertical side of the rectangle is 2m squared n. The 2 slanted sides of the trapezoid are each 3m squared n. And the bottom side of the trapezoid is 5m squared n. Let's start by finding the perimeter of this figure. The perimeter is the sum of all 6 sides, 3m squared, n plus 2m squared, n plus 3m squared, n plus 5m squared, n plus 3m squared, n plus 2m squared n. Combining like terms, we get 3 plus 2 plus 3 plus 5 plus 3 plus 2, all multiplied by m squared n, which equals 18m squared n. To find the area, we'll divide our shape into 2 parts, a rectangle at the top and a trapezoid at the bottom. Then we'll calculate each area separately and add them together. First, let's find the area of the rectangle. The area of a rectangle is base times height. So we have 3m squared n multiplied by 2m squared n, which equals 6m to the 4th power n squared. For the trapezoid, we first need to find its height x. We can use the Pythagorean theorem on the right triangle formed by dropping a perpendicular from one corner. The hypotenuse is the slanted side, which is 3m squared n. The horizontal leg is half the difference between the parallel sides, 5m squared n minus 3m squared n divided by 2, which equals m squared n. Using the Pythagorean theorem, x squared equals the hypotenuse squared minus the base leg squared. 9m to the fourth power n squared minus m to the fourth power n squared, which equals 8m to the fourth power n squared. Taking the square root, we get x equals 2 root 2m squared n. Now, we can find the area of the trapezoid. The formula for the area of a trapezoid is 1/2 times the sum of the parallel sides multiplied by the height. Substituting our values, 1/2 times the sum of 3m squared n and 5m squared n multiplied by 2 root 2m squared n. This simplifies to 4m squared n times root 2m squared n, which equals 8 root 2m to the fourth power n squared. Finally, we can find the total area by adding the areas of the rectangle and trapezoid. Total area equals 6m to the fourth power n squared plus 8 root 2m to the fourth power n squared, which equals m to the fourth power n squared times the quantity 6 plus 8 root 2. Let's summarize our results. The perimeter of the figure is 18m squared n. The area of the figure is 6 plus 8 root 2 times m to the fourth power n squared. Welcome to our math problem-solving session. Today, we'll be solving a geometric problem involving a composite shape with various measurements in terms of x and y. Let's look at our problem. We have a composite shape that consists of a rectangle with a right triangle attached to it. Various sides are labeled with expressions involving x and y. The left side of the rectangle is labeled as 3xy. The bottom of the rectangle is labeled as 4xy. The top of the rectangle is also 4xy. The hypotenuse of the triangle is 5xy, and there's an unknown length labeled as a. We need to find three things. First, the value of a in terms of x and y. Second, the perimeter p of the entire shape. And third, the area a of the entire shape. Let's start by finding the unknown value, a. We can see that a is the base of the right triangle on the right side of our shape. This triangle has a height of 3xy and a hypotenuse of 5xy. We can use the Pythagorean theorem to find a. Remember, in a right triangle, the square of the hypotenuse equals the sum of squares of the other two sides. So we can write a squared plus 3xy squared equals 5xy squared. Simplifying the squared terms, a squared plus 9x squared y squared equals 25x squared y squared. Solving for a squared. A squared equals 25x squared y squared minus 9x squared y squared, which gives us a squared equals 16x squared y squared. Taking the square root of both sides, a equals 4xy. Now that we know a equals 4xy, let's find the perimeter of the entire shape. The perimeter is the sum of all the sides of the shape. Let's identify all 5 sides. The left side of the rectangle is 3xy. The bottom of the rectangle is 4xy. The value of a, which we just found to be 4xy. The hypotenuse of the triangle is 5xy. And the top side of the shape is 4xy. Adding all these lengths, p equals 3xy plus 4xy plus 4xy plus 5xy plus 4xy, grouping like terms p equals 3 plus 4 plus 4 plus 5 plus 4 times xyp equals 20xy. Finally, let's calculate the area of the entire shape. We can split our shape into 2 parts, a rectangle and a right triangle. For the rectangle, width is 4xy, height is 3xy. So the area of the rectangle is 4xy times 3xy, which equals 12x squared y squared. For the triangle, base is a, which we found to be 4xy, height is 3xy. So the area of the triangle is 1/2 times base times height, which is 1/2 times 4xy times 3xy, which equals 6x squared y squared. The total area is the sum of these two areas. A equals 12x squared y squared plus 6x squared y squared. A equals 18x squared y squared. Let's summarize our answers. 1. We found that it equals 4xy. 2. The perimeter of the entire shape is 20xy. 3. And the area of the entire shape is 18x squared y squared. We solved this problem by using the Pythagorean theorem to find the unknown side length, adding all sides to calculate the perimeter, and splitting the shape into simpler geometric figures to find the total area. Welcome to this math tutorial. Today, we're going to solve a geometry problem involving a square with 4 circles inside it, and we'll calculate the area of the shaded region as an expression involving the variable a. Let's start with our problem. We have a square with 4 equal circles inside it. The blue region is what remains of the square after removing the 4 circles. We need to express the area of this blue region as a polynomial expression in terms of the variable a, where it represents the radius of each circle. First, let's determine the side length of the square. Each circle has a radius of a, so its diameter is 2a. Since the square perfectly contains the 4 circles in a 2 by 2 arrangement, the side length of the square must be 4, which is the sum of the diameters of 2 circles placed side by side. Now, let's calculate the area of the square. The area of a square is the side length squared. So, the area of our square is 4a squared, which equals 16a squared. Next, we need to calculate the total area of all 4 circles. The area of a single circle with radius is pi times a squared. Since we have 4 identical circles, the total area is 4 times pi times a squared, which simplifies to 4 pi a squared. Now, to find the area of the blue shaded region, we need to subtract the total area of the 4 circles from the area of the square. So, the area of the blue region is 16a squared minus 4 pi a squared, which simplifies to 16 minus 4 pi times a squared. Finally, let's identify the degree and numerical coefficient of our expression. The degree of our polynomial, 16 minus 4 pi. A squared is 2, since the highest power of it is 2. And the numerical coefficient is 16 minus 4 pi. Thank you for watching. Don't forget to like, subscribe, and hit the bell icon for more math lessons. NENOMATICA, where mathematics meets YouTube excellence.